In this video, we are going to talk about some Section B probability problems which are not using NPR or NCR. Before that, you should learn about Section A probability problems. And then for the NPR and NCR, the skills involved for the NCR, the three skills as shown, they are very useful. Also, you need to recognize which problems should be using NPR or NCR. Finally, we will use a tree diagram to help you know which cases are involved. We will use this question from the sample paper to demonstrate. So here we are going to draw a ball, and then from back A we have 2 red balls, 3 green balls and 4 white balls, in total 9 balls. And then for back B there are different numbers of balls for different colors. And then we draw 1 ball from each back, and then you are asked to find the probability that 2 balls are drawn of different colors. Now we are going to use a tree diagram. For back A we have 3 different kinds of results. So we have the R for the red, G for the green, and then W for the white. So we have 3 branches, and then there are 2 red balls out of 9 balls, so the probability of getting a red ball is 2/9. Similarly, for the green balls it is 2/9, which is 1/3, and finally it is 4/9 for the white balls. And then we are considering the back B, so there are also 3 different results as shown, and then the probability are also written down there for your reference. After drawing a green ball from the back A, there are also 3 possible results from the back B, and then similarly for the white ball from the back A as well. So the red line shows that we get a red ball from the back A and also a red ball from the back B. The probability of having this event is very simple. Remember, within the same case we use multiplication, therefore we multiply both probabilities. Therefore it is 2/9 times 2/9. We demonstrate again. So if we get a red ball first and then a green ball from the back B, the probability is 2/9 times 1/3. Therefore, you can find out the probabilities for all the 9 cases in the tree diagram. So how to find out the required probability? You need to know how many cases are involved. So the first one is red and then green, and then the second case is a red ball and followed by a yellow ball. So you can find out all the cases. Remember that within the cases, you use addition to join them together. So method 1, you simply count all the cases and add them together. However, you find that it is a little bit time consuming. So we may use a simplified tree diagram. For the back A, we are using exactly the same diagram. So for back B, we just need to know whether it's a red ball or it is not a red ball. For not having a red ball, you add the green and the white balls together. So there are 7 balls out of 9, which is 7/9 for the probability. If we simplify the cases like this, there are only 3 cases now, which is the first one is red and the second one is not red. And then the second case is the first one is green and then the second one is not green. And finally, the first one is white and then the second one is not white ball. So we simply add these 3 cases together, which is much simpler than method 1. So for the third method, we need to understand that for 2 balls, they are either of different colors or having the same color. Therefore, the probabilities of them will be equals to 1, which is the total value for the probabilities. So the required probability can be found out by using 1 minus the probability of having 2 red balls and then minus the probability of having 2 green balls. So it equals to 1 minus 2/9 times 2/9, and then minus 3/9 times 3/9, which equals to 68/81. That's it. Hope you like this video.